All right, problem 9, geometry problem. In a triangle ABC, points M and N are the midpoints of the sides AB and AC respectively. How large is the ratio between the area of the quadrilateral BCNM and the triangle ABC? Oh boy. This is scaring me a little bit, to be totally honest with you. I'll tell you why. First of all, there's no figure that goes along with this problem, and there's a whole lot of A's and B's and M and N's and words like midpoints and ratio and quadrilateral, and so there's a lot going on here. So I can see how this might be a little bit daunting, but I always have a thing up my sleeve. I always have a something up my sleeve whenever I encounter a problem like this, and that is if there's no figure given and there are shapes that you're working with, you always want to start with making that shape. This will give you a much more kind of concrete image of what you're working with, and your brain is going to start working right away from that. So let's start with that. So I'm going to make my figure here on the right side. All right, so it says a triangle ABC. Now, be careful when you're making this figure, because you don't want to fall into the trap of making a very specific kind of triangle that you like to work with. For example, if you were to make a right angle triangle here, or an isosceles triangle or something like that, then you might fall into the trap of seeing some things that are not actually going to be valid, because in this case, all we're given, the information we're given is that it's a triangle. So I'm going to make the most general triangle that I can from this information. So let's start with A here. Let me make the A a little bit bigger. And then we're going to go with a straight line here. And we're going to have B. Then I'm going to say that C is somewhere here. Now let's see. Now this is going to be tough. How do I create a line that goes fairly straight up here? I'm going to be... okay, that's good enough, I suppose. And... not the best looking triangle, but it's okay, I suppose. ABC, there we go. So we got those. Now it says M and N are midpoints of the sides A and B. Okay, what that has to mean is that you take the length, you cut it in half exactly, and that's where these points are going to be. So A and B, so for M, that's the midpoint for side A and B. Let me make sure that make it right around here, perhaps. M. And then we have A and C up here. That's right around here, I would say, and that's N. Okay. How large is the ratio between the area of the quadrilateral? Now, quadrilateral, if you don't remember, that's just a shape with four sides, right? It can be a rectangle, can be a square, but it can also be like any other shape. So B, C, N, and M. So that means that I gotta make a line here, like so. And so, of course, this would be the quadrilateral. So what's the ratio between the area of the quadrilateral and the triangle ABC? So obviously, I see that ABC triangle is something that's bigger than BCNM, and BCNM is a shape that is a part of the larger shape ABC. All right, so I'm going to write down what it is exactly that we're looking for, because the ratio would be, we would have... the ratio would be, let's say ratio would be area. So let me say B, C, N, M divided by A, B, C. That's what we're after. Okay, so did that make it any easier? I don't know. Let's have a look at the figure. Well, the first thing I'm seeing here is that this is the points M and N are exactly at the middle of AC and AB, which leads me to believe that this length, or this side and this side, are parallel, right? Parallel lines like this. Is that so? Let's see. So if this point right here, the C point, was moved around, let's say that it was around here, then there would be a line going like this, and then there would be the middle of this line going like this. So indeed it looks like, because we're exactly at the midpoint for both points, whenever they move, they're gonna have that property. So okay, that's good to know that those two are parallel lines. What else can we think of? So we want to find out the area of this thing, A, C, N, and M. Okay, so let me try to use a different color here so we can do some things here without messing up the original figure. So if I draw a line like this, if I were to draw a line like this, I can see that this can be made into a square. If there was a midpoint that we drew a line at here, let's call that P, for example, then this would be a square, or this would be a rectangle rather. So what if we continued that? What if we continued that line down like this? And what if we continued this? Now I'm just trying some stuff out. Let's see. Okay, that's interesting. And then you could indeed like just continue like this. And then you could connect this together. And then you would have a line like this. All we've done is that we've mirrored this, across this line. Or mirrored this and then kind of rotated it too. But this whole thing now, we started out with a triangle, but now we have a rectangle. And so for each one of these, you have these rectangles, and then each rectangle can be sliced up into triangles. Okay, that's starting to get interesting. Okay, this is interesting. Now let me think about, are we given, if we're working with areas, then we have to have some of the sides of these things, right? Because if we're not given a side, how can we figure out the area? Yeah, that's a tough one. But are we after a specific area as the final solution for this, or are we looking at something like ratio? Well, we're looking at ratio, which means that the specific length doesn't really matter that much. Because we're after the ratio, we're really looking at the ratio between them. So what I could do here is just give some sort of length to one of the sides to this. So let me say that the sides, sides A and A to C. And so there's an A to N and then an N to C. What if I were to say that, I know that there's the midpoint, right? So this length is the same as this length. Let me just give those lengths the length 1 and 1. Now, what would this length be? Well, let me give that. Now that I can't just give a length, right? Rather than because that's another side of this triangle. But I could give it a length of something that could be anything. Let's give it a length of x. And then, of course, because P is the midpoint here, then the length of this one would also be x. Okay, does that get us any closer to the solution? Well, I think so, because we've already sliced up this thing into smaller pieces. And what's the area of this piece? Let's say that we have this thing right here. What's the area of that? Well, we have both sides, x and 1. So that will be, 1 times x. That would just be x. X is the area of this one. Now, what is the area of this thing? Well, that's again just 1, this thing, times this thing, right? Because this and this are the same. These two sides are the same. Now, what specifically is going to be the area of this triangle, not the rectangle? It's just going to be half of that, right? Because we're just doing a diagonal to slice those things up to 2. So that would be x over 2. Well, again, this side right here is also, there's an x here, and then there's this side right here, which is 1. We already know this from here. So again, that's also going to be, that's also going to be x over 2. I think we're getting somewhere now. So from this, we deduced that if we were to recreate these, let me go back to a black pen. Let's do B, C, and M. That's going to be this and this. Oops, sorry. My bad. Not that first triangle. It's just this and this. Right? It's this part and this part. Okay, so that's, we figured out, is x plus x over 2. And then there's the ABC, which is going to be the entire triangle, which is split up into this, which means that it's x plus x over 2 plus x over 2 again. Okay, well, I think we're getting pretty close to something. If we were to simplify this, we could just do 2x over 2 plus x over 2, which gives us 3x over 2. And then this, of course, would give us x plus half x, half x, half x, of course, 2 times together makes a whole x. So that is going to be a 2x here. All right, so we got this one and we got this one. Now the ratio, coming back to that one here, ratio would be this first thing, B, C, and M, which is 3x divided by 2. And then all of that divided by 2x. Well, what's that going to be? Well, using some simple fraction rules, what we'll get then is that we'll have 3x divided by 4x. And this is where the beautiful thing happens, which is we can cancel the 2x's, which is what I was expecting because it's a ratio, which is why it was fine for us to give us this length and, an x length to one of the other ones. That, of course, is going to give us 3 over 4. Which one is that? That's D. So D is the right answer. There you go. I hope you enjoyed this one. I hope you learned something from this. What I usually recommend with these geometry problems, which can be a little bit daunting, is that as long as you have a figure to play around with, you can see that you can change the figure. You can extend the figure, and you can start seeing that what we did here, which was the key insight, was that because of the way that the figure was designed, with the midpoints and everything, it very conveniently gave us 2 lines that were parallel to each other. And given that's true, we kind of extended it out and saw that we have rectangles that could be made, and you can slice up those, and that's exactly what together made the figure. And of course the ratio is also something that was key, because that allowed us to work with some more concrete values, and that allowed us to give length to some of these sides, which would of course allow us later on to just cancel those out, because we're dealing with a ratio and not just a raw area. There it would be harder to do that if we had something like that. Okay, see you in the next one.